Hi guys, let's continue to solve problems. In this video there is a cascade amplifier. So I did not mention about cascade amplifiers, but it is simple guys. Think about it like this. There is an amplifier and this is V input. The gain is A and V output one will be A times VI. And if this is another amplifier's input, then again if gain is B, then output will be A squared times VI. That means we multiplied the gain. So in cascade amplifiers we multiply the gains. I mean, in this circuit, let's look at the circuit. Here VI. So remember, in AC case this is short circuited. Here VI, here we output 1. Here there is emitter follower, and then we output 1. Here there is VO, and then common emitter BGT. You see, these two gain will be multiplied. I mean, V output over VI will be V output 1 over VI times V output over V output 1. That's it guys for cascade amplifiers. So let's solve the question. In question, beta force is 100 is given, with thermal voltage is 26 millivolt, and VBE, absolute value of VBE is 0.6 volt. Find DC collector currents of the transistors. Okay, in DC case, remember, capacitor here are open circuited. There will be no current passing through, and there will be no current passing through these capacitors. So in DC case, my circuit becomes like this: VCC 10 volts, and then 10K, here 40K, and then my transistor comes 7.4K, $2K. This is PMP by the way, and there is 4K here. We should find IC1 and IC2. So in this question, what we can do is, let me write it properly. What we can do is, this is 7.4K. Here there is, actually we can solve this question approximately. How? I mean, if this is 10 volts, here, this is 10 volts, we can say that approximately this voltage is 8 volt. Why? There will be a voltage divider and we can ignore base current. Why we can ignore base current? Think like this. If here is 8 volts, there will be 2 volt voltage drop here, and 2 volt divided by 10, there will be 200 microampere flowing through this resistor. So there will be also 8 over 40, 200 microampere flowing through this side. I mean, think like this: if this is 8 volt, then here becomes 7.6 volt, since VB is 0. It becomes 7.4 volt since VB is 0.6 volt. Then I know that there is 7.4 voltage drop here, so IC1 simply equals 7.4 volt divided by 7.4K, and it is 1 milliampere. Also, we should ignore the IB2 current. Generally we cannot ignore them, but in this question the question wants us to ignore it, because there is nothing else is given. I mean, okay, this is 1 milliampere, and so if IC1 is 1 milliampere, let's check it. If IC1 is 1 milliampere, then beta force is 100, then 1 milliampere divided by 100, this is 10 microampere, and it is small compared to 200 microampere. It is small, and you can say approximately this is 8 volt. So our approximation is true. Okay, in the second question, since here 7.4 volts, here this voltage becomes 8 volts. Why? Because there will be VEB 0.6 volt voltage drop. So there is 2 volt voltage drop here. There will be 1 milliampere flowing through here. So second, there will be 10 microampere base current of second amplifier. So actually IC1 is actually not 1 milliampere. IC1 is 1 milliampere minus 10 microampere, and it is like 0.99 milliampere. You can see, you can ignore base currents in this question. Let's say this is IC emitter. Let's say IC1 is 0.99 milliampere. I mean, it is negligible. 0.01 milliampere, you can neglect it. It's not that important. So IC1 is 0.99 milliampere, and IC2 we have found 1 milliampere. So this was the DC currents. In the second case, find V output over Vi of the circuit. It wants us to find gain. For finding gain, remember, also section C, find AC model of the circuit. Okay. For finding gain, we should need GM values. GM1 is 0.99 milliampere. We can say it is approximately 1 over 26 millivolts, and it is 38.46 millisiemens, and GM2 is 1 milliampere divided by 26 millivolts, and it is also approximately 36 over 38, no, not approximately, it is equal 38.46 millisiemens. Here it is approximately 38.46 millisiemens. So the question wants us to find AC voltages, so AC gains. VO over VI. I have told you that VO over VI equals VO over V output 1 and V output 1 over VI. So we should first find V output 1 over VI. Here this is V output 1. Okay. This is emitter follower structure. When you look at the circuit, this is emitter follower input. In AC case, remember, capacitors are open circuited. Here capacitors are open circuited and DC voltage supplies will be grounded. So this resistor is short circuited. It goes ground like this. Here we output. Here you see 10K parallel to 50K, and it is like 0.8K here. Okay. So my circuit in AC case, let's draw AC equivalent of this circuit. Here 0.8, no. Here there is 8K. I'm looking my circuits, and then here it is grounded, and then my MPN here 7.4K. Here grounded again, and there is RC2 which is 4K. The output is here. So I know GM1 and GM2 values, so I can find the AC gain. Here what I see from here as a resistance is RB2, and remember RB2 was equal to beta force over GM2. if there were RE resistance here, we would write beta plus 1 times R emitter 2, but there is no RE resistance in this case, so we do not write this term. It is grounded. Emitter is grounded, so beta force over GM2 is RB2. Let's find this value. It is 100 over GM2, 38.46 millisiemens. It is 2.6K. RB2 is 2.6K. So, the first gain will be here. This is V output 1. Here, this is Vi. So, V output 1 over Vi equals GM. Remember the common emitter gain formula. I will give you again. I will repeat this until you get used to and know it by heart. Common emitter gain formula. It is GM array over 1 plus GM array. But be careful. What is our emitter resistance in this case? In this circuit, it is 7.4K parallel to RB2. So, my gain V output 1 over Vi simply equals 38.46 times 7. Sorry, let's write it here. V output 1 over Vi, it is 38.46 times 7.4K parallel 2 plus 6K divided by 1 plus GM, which is 38.46 times 7.4K parallel 2.6K. So, if I calculate this value, let me calculate it quickly. (7.4K parallel 2.6K is 2.6 inverse plus 7.4 inverse. It is 1.924K. So this times 38.46 divided by, it is approximately 0.986. 0.987. This is first gain. Let's find the second gain. So second gain is, let's look at my AC equivalent circuit. It is here V output 1. So VO over V output 1. So second gain is common emitter gain formula. Remember the common emitter gain formula. Common emitter gain formula was minus GM RC over 1 plus GM RE. But in this question, there is no emitter resistance. Emitter is grounded. Look at here. So this term goes away. It is minus GM times RC, and in this circuit, RC2 is simply 4K. Because when I look at here, I see RCE resistance, and simply there is no VA given in the question, so we take it infinite. So if VA is infinite, RCE is also infinite. My output resistance becomes approximately 4K. So my second gain is VO over VO1 is minus 38.46 times 4K. And it is 153.84. So my overall gain simply becomes VO over Vi, the multiplication of these two gains here, it is 151. 51.84. I mean, it is approximate value. I mean, we did approximations. The exact result is not this, but approximately equal to this. Maybe 160 is the actual result, but 151 is okay. It is near enough. In engineering, we have a saying: near enough is good enough. So in section C, we should draw the AC equivalent of circuit. Let's quickly find our input and our output of the okay. This AC equivalent circuit, our input simply equals, remember, I will take this. No. Remember, what was our input? Our input is, this time, we look at from here. Here. So, what is our input? It is what we see from here at the base of second transistor is RB1. So let's find RB1 first, because our input simply RB1 parallel 8K. So what is RB1? RB1 is beta force over Gm2, which is 38.46 millisiemens, plus beta plus 1 times RB2. We have calculated RB2, where we have found here it is 2.6K. I mean RB2 parallel 7.4K. Sorry. .4K parallel RB2. We also found this value. It is 1.924K. 1.924K. So RB1 equals what I am doing right now is think like this. What is RB1? It is beta force over Gm2 plus beta plus 1 times what we see at the emitter. What we see at the emitter is 7 plus 4K parallel RB2. So let's find RB1. RB1 equals plus 101 times it is 194K. So our input simply becomes 194K parallel 8K. We can say it is approximately 8K, because 194 is like more than 20 times. It is negligible. Our input like it is 8K. What is our output? Our output simply is RC2. I have told you that because what I see here is RCE, and RCE is infinite in this question, where R is infinite. So our output simply becomes 4K. So my AC equivalent of circuit becomes, here we input, here our input 8K. Sorry, in gain formula there is minus here. Minus 110, because minus sign comes from here, minus 151.84. So my gain AC model becomes like this: 151.84. Here minus, it is plus, arrow is 4K. This is my AC equivalent of my circuit. When I look at this AC equivalent, what I see, is input resistance is 8K, gain is minus 151.84, and our output is 4K. That's it guys. See you at the next videos. Take care of yourself.